of an ultrasonic production method, piezoelectric effect, which is based on the inverse piezoelectric effect principle. In this figure, you can see that if the frequency of the applied alternating voltage is equal to the vibrating frequency of the crystal, then the crystals will be thrown into the resonant and the vibration producing ultrasonic wave. As shown in figure, we can write a construction of this piezoelectric method. The quartz crystals Q was placed into the between the A and B plate. The plate A and B are connected to the coil L3. The coils L1, L2 and L3 are inductively coupled to the oscillatory circuit of a transistor. The coil L2 is connected to the collector circuit, while the coil L1 with a variable capacitor C1 forming the take circuit is connected between the base and the emitter. The battery is connected between the free end of the L2 and the emitter of the transistor. You can see the frequency of this producing of ultrasonic wave is F is equal to 1 upon 2 pi root of L1 C1. By adjusting the variable capacitor C1, the crystal is set into the one of the modes of the resonant condition. Thus, the vibrating crystal produces a longitudinal ultrasonic wave in the surrounding air, and the frequency will be F is equal to P upon 2L under root E by 2 E by rho, where the E is the Young modulus, rho is the density of the materials, and P is the fundamental overtone. P is equal to 1 for the first fundamental overtone, P is equal to 2 for the second fundamental overtone. And finally, when 1 upon 2 pi under root L1 C1 will become equal to rho upon 2L under root E upon P, then production of ultrasonic wave will there. Merit, or you can say application. The output of this oscillator is very high. High in the sense of frequency, you can generate a 500 megahertz by using this. It is more efficient than the magnetostriction oscillator. It is not affected by the external parameters like temperature and the humidity. And the disadvantage, or you can say demerit, cost of piezoelectric method is very high compared to the magnetostriction effect. It has a lower power handling capacity. Next question, what is acoustic grating? Explain the acoustic grating method to determine the velocity of an ultrasonic wave in liquid. My friends, this question is belong to a unit, ultrasonic wave. Acoustic grating. First of all, what is the meaning of acoustic grating? When the ultrasonic wave are passed through the transparent liquid medium in a container, the wave get reflected back, and that reflected wave is called echo. Container can be used, you can use a glass. The direct and reflected wave will superimpose on each other, and thus they forms a stationary wave patterns. The wave give rise to a periodic vibration in the density of the liquid. Then in the change in the density tends to variation in the refractive index, and the density of the liquid would be maximum at the nodal points and would be a minimum at the antinodal points. Resultant, there will be a formation of liquid column, and it is subjected to a ultrasonic wave detection. Under this condition, if a parallel beam of a light is passed through a liquid at a right angle to the wave, the liquid acts as a diffraction grating, and this diffraction grating is called acoustic grating. Experimental technique. Experimental techniques you can show in below figure. There is a glass vessel containing the liquid with the reflector R fixed with the vessel at its tops. This is the construction of an acoustic grating. Left hand side you can see the sodium source, which is a monochromatic source. Then you can see right hand side a telescope. Between the telescope and source there will be a glass container. At the bottom of the glass container there is a ultrasonic oscillator, and the quartz crystals is placed between the two plates. And right hand side you can see the pattern or the metallic plates are connected to an oscillator whose frequency is so adjusted that the crystal vibrates in the resonance with the frequency of the oscillator, and thus finally there will be a production of an ultrasonic wave within the liquid. Due to the production of an ultrasonic wave within the liquid and at the top of the container, the reflected ultrasonic wave and incident ultrasonic wave will superimpose and will forms a stationary pattern. Finally, this liquid behaves like a grating. The acoustic grating is mounted on the prism table, and the monochromatic source S is passed through the liquid at the right angle to the wave. Since the liquid is behaving like an acoustic grating, the light beam which is passing through that will get diffracted and produce a diffraction pattern, and that diffraction pattern is viewed through the telescope. The diffraction pattern consists of a central maxima of a difference order. If the angle of the diffractions for the nth order principal maxima, then we can write equation d sin theta is equal to n lambda, where lambda is the wavelength of the monochromatic light source, d is the grating element, means a distance between the adjacent nodal planes, and it is defined as grating element. So you can write a grating element by d is equal to lambda u by 2. Lambda u is the wavelength of an ultrasonic wave. Then lambda u by 2 sin theta is equal to n lambda, or you can write lambda u is equal to 2n lambda by sin theta. Thus, if you know the value of a lambda and the value of n, so by measuring a theta, you can find a wavelength of an ultrasonic wave. If the resonant frequency of the ultrasonic generator is small f, then the velocity of an ultrasonic wave will be given by v is equal to f into lambda u. Next question. This question is based on the laser. Explain the construction and working of a ND-YAG laser. Active medium. This is a 4-level solid-state laser system. Yttrium aluminum garnet, commonly called a YAG, is doped with the neodymium, is an active medium, where Nd3 plus ions are the active centers. Then about the optical pumping, a photon flash lamp or a krypton flash lamp are used for the optical pumping source. Resonator cavity. The end face of the ND-YAG rod are ground polished and silvered to act as a optical resonator mirrors, or the optical cavity can be formed by using two external reflecting mirror, M1 and M2. Here you can see the construction or a circuit diagram of a ND-YAG laser. there will be a two mirror is there, total reflector and output reflector. In the middle there will be a there is a ND-YG crystals, and upper side and lower side of the ND-YG crystals there is a flash lamp which is directly connected to the power supply, and right hand side there is a output of a laser light. How it works? In order to make an entire flash radiation to focus on the laser rod, the ND-YG rod is placed at the one focal axis and the flash lamp at the other focal axis of the ellipsoidal reflector. When the flash lamp is switched on, the Nd3 plus ions forms the generated energy into the state E0. These Nd3 plus ions will jump from E0 to E3, where E3 is the higher energy level, and then in E4 by absorbing a radiation of the wave of an 0.80 micrometer and 0.73 micrometer wavelength. This is the energy level diagram. In this you can see from E0 there will be a transition to E3 and E4, and from E4 there will be a transition into the E2, which is a metastable state. E4 to E2 is a non-radiative transition. From E2 to E1 there will be a production of a laser which has a wavelength near about 1.06 micrometer, and finally from the E2 to E1 to E0 there will be a once again non-radiative transition. Then you have to write about this whole process. Finally, the application of this. This is a solid state laser which is widely used for the cutting, drilling, welding and surface hardening in the industrial. These lasers are used in military as a range finder and as a target destination. It is used in a long haul communication. It is used in a study of a inertial confinement fusion, and it is also used in a medical field for the surgery or the gastrointestinal bleeding and the bladder surgery. Next question. Write a short note on application of laser. This is also belong from the laser unit. First application of a laser light in industry is it can be used for the larger extents for the following process: for welding, melting, cutting, drilling, or test of a quality materials, or a heat treatment of a metallic materials. Then in medicine, it can be used for the surgery. It can be used for the treatment of a human as well as animal cancers, and as well as skin tumors. In military, we already seen in ND-YG laser, a powerful laser beam can be used to destroy in a few seconds in the big size objects like aeroplanes, missiles, etc. That's why the laser ray is also called a death ray. Also, it can be used to determine the distance, the velocity and the directions, as well as the size and the form of the distant object. In science and engineering, it is used in fiber optical communication. It is also used in communication between the two planets. It is also used in holography, and it is also used in accelerating some chemical reaction. These are further two applications of an ultrasonic wave. In that, it is also used in underwater communication and also used to forms a new chemical compounds. Next question. What are superconductors? Explains a few property of an superconductors. This question is belong to a superconductor units. What are superconductor? First of all, you have to give the definition of a superconductor. Basically, a superconductor are a materials who lose the resistivity below some particular value of a temperature. That particular value of a temperature is called transition temperature. Below the transition temperature, superconducting materials will behave or will react a zero electrical resistivity. That particular temperature is called transition temperature. The first properties of an superconductor is electrical resistance. As we shown in a definition of an superconductor, it possesses a zero electrical resistance. It is near about 10 raised to minus 7 ohm into meter. Second property of the superconductor is effect of an impurity. When you add an impurity into the superconducting materials, then superconductivity of that particular materials will not lost, but a value of a transition temperature can be lowered. For example, third properties of an superconducting materials is effect of pressure and stress. Certain materials in our periodic tables are found to exhibit a superconductivity under the phenomenon in increasing a pressure or a stress. For example, cesium is a materials which found to be exhibit a superconductivity under the application of an 110 kilobar pressure. Under the pressure 110 kilobar, this cesium is behave as a superconductor below a temperature 1.5 Kelvin. Isotope effect. The critical or a transition temperature Tc of a superconductor is found to vary with the different isotope. And the relation between the transition temperature